Good evening, Cardinals. It's me, Mr. Ernst, and I'm here today to talk to you about I think this is 7? I keep losing track of which one I'm on. Part 7 of the assignments for this week. Again, as always, I would love for you guys to try and do this assignment on your own first, but if you do find that you're struggling, please feel free to come to this video where I can help you out. So, we're looking at this situation here. Trevor is at baseball practice. He is curious about the tall light poles around the field. It is late in the day, so the poles cast a long shadow. To compare his shadow to the shadow of a pole, he stands as shown below. The tip of the shadow is at the same point as the tip of the light pole's shadow. Cool? So we have the light pole, we have Trevor, and we have the shadows that both of them are casting. So this is going to be the light pole shadow, and then this part right here is going to be Trevor's shadow. So there's a lot of different little pieces going on here. This is modeled as a very simple triangle, two simple triangles. You have one small triangle here, and then you have one much larger triangle that's kind of woo. You have one much larger triangle that's kind of chilling here. So you got two triangles here that we're kind of working on with this. So it tells us that Trevor is 6 feet tall and his shadow is 8 feet tall. So we're going to go ahead and start filling in parts of, actually, you know what, let me see if I can pull this out and make this a little bit bigger, because I think this is going to be too small for me to try and work with as is. Perfect. Whoop. Much better. Lots more room to work with this. Okay, so I'm going to just basically write in the different information we're given. Trevor is 6 feet tall, and his shadow is 8 feet long. So we know that Trevor is 6 feet tall, and his shadow is 8 feet long. Again, both of these are measured in feet, so everything is in feet. The light pole shadow is 80 feet long. So from here all the way over to here is 80 feet. So, A, how tall is the light pole? So our first thing is to find out this. This is our unknown value here. So any unknown value that we don't know, we usually represent with a variable such as x. So we need to find this value here. Now, this might not be something that is immediately obvious, but it might become a little bit more obvious if you separate these two triangles. So for example, if I have my small triangle here, oh gosh, hold on. Let me get my line tool because that is just not going to come out looking right. There we go. Small triangle and big triangle. So I've separated them out. All I've done is just separated this small triangle from the big triangle because they're kind of laying on top of each other. We know from the small one that this side is 6 and this side is 8. I know the bottom of the large triangle is going to be 80, and that this side over here is my x value. Cool? So remember that when we're looking at similar triangles, and we know that these are similar because they lay on top of each other, we know these are two similar triangles, which means the pattern here is going to be very much the same. 8 is related to 80, and 6 is going to be related to whatever our x value is. So in other words, when this small triangle was dilated up, it was made bigger into this triangle, what did 8 have to multiply by to give me 80? 8 had to multiply by some number to give me 80. And if you're thinking ahead, it's going to be 10. So if 8 had to multiply by 10 to give me 80, that means 6 also had to multiply by 10. Again, if these are similar triangles and they were dilated, that means all three sides, even this last mystery side over here, all three sides would have to, multiply by the same scale factor. All of them have to be multiplied by the same scale factor. Cool? Well, we're not worried about that third side. So 6 times 10 simply gives me 60. So the answer for our first one, how tall is the light pole? 60, and then we always want to remember our measurements, feet. 60 feet. Question B, how far is it from the top of Trevor's head to the tip of his shadow? Okay, so we don't need these anymore. Take all of these out. We don't need this anymore. How far is the tip of Trevor's head to the tip of his shadow? So now we're trying to find from here, the tip of Trevor's head to the tip of his shadow, which is down here. So now we're trying to find that. And once again, might not be immediately obvious, but if you were to separate it, we have an 8 on the bottom, a 6 on the side, And we don't know what this last side is, the longest side, aka our hypotenuse. In fact, I'm going to go ahead and label that C. So we don't know what our longest side is. Well, this comes back to the plain old a squared plus b squared is equal to c squared. Or in other words, 6 squared plus 8 squared is equal to c squared. From this, you go through, from this point at least, you're going to go through, simplify these two, add them together, and at the very end you will have to take the square root. So let's go ahead and go through that all together. 6 squared is going to give us 36. 8 squared is going to give me 64, is equal to c squared. 36 plus 64 gives me 100, is equal to c squared. I have to take the square root of both sides, which means I'm left with regular c, because the square root cancels out this. These two cancel each other out. So I have c is equal to, and the square root of 10 is, or square root of 100 is 10. So c is equal to 10 feet. Don't forget the feet part. Final question. How far is it from the top of the light pole, so this time we're looking at way up here, top of the light pole, to the tip of its shadow? All the way down here. Same type of problem from beforehand. Might help to draw out a model. I know the bottom of the large triangle is 80. I know from our answer earlier that the height of it is 60. And again, we're looking for c. Once again, you can go through the Pythagorean theorem here, but there is a shortcut. Well, actually, let's just go through this as per usual. A squared is going to be 60 squared this time. This one's going to be 80 squared. And then the last one's c squared. So now we have 60 times 60, which is still going to give me 36, but now that we have this, there's going to be 2 more zeros on there. And I'm going to double check myself because I'm suddenly not so sure. Yeah, that's what I thought. Okay. All right, so we got 3,600. I'm going to write that down like here. 3,600 plus 80 times 80. Just like before, it still gives me 64, but we're going to have the 2 zeros in there as well, is equal to c squared. Add these two together, we're going to get 10,000 is equal to c squared. Take the square root of both sides. Cool. So we're looking at what number multiplied by itself is going to give us 10,000. C should be equal to 100. And that would be answer to letter C. This problem, or this page, I guess, continues on to the next page, but it doesn't have anything to do with triangles anymore. So I'm going to erase all of this stuff and we'll move on to the next problems. Problem 2. Oops. Hold on. Bam, there we go. All right, problems D and E. First one. Trevor used reasoning about shadows to estimate the size of a storage building in the shape of a cone. So we're dealing with a cone, which is we draw by making a circle and then 2 lines coming off of it, just like that. Cool. In the shape of a cone, he estimated the diameter of the base. Remember, a diameter goes from one side all the way to the other side of the cone. Diameter of the base of the cone would be about 50 feet. So from here all the way to the side would be 50 feet. Cool? I'm going to actually just put 50 and then write feet over on the side so I can remember. I don't have to write feet every time. He estimated the height of the cone. So from here down, the height of the cone is going to be 60 feet. So we have 50 down here and 60 here. What is the approximate volume of the cone? Now, this was one of the things that we kind of talked about with memorizing the different volumes. Volume of a cone is the volume of we start off with a circle, pi r squared. We need to make this into a cylinder by multiplying it by its height. So that's a cylinder, looks like a little Coke can. And then we have to multiply the height, all of this, we have to multiply it by 1/3. And that's what shaves the cone down, or the cylinder down, to make a cone. And now we have this. So pi r squared times height times 1/3. Now we just have to plug in our variables, and our variables are height and the radius. The height that it gave us was 60, so I'm just going to plug 60 in. Now the radius is not 50. 50 is the diameter, which is the full thing. A radius is only half of the circular base, which means we need half of 50. So the radius is actually going to be 25. Cool? Volume is equal to pi multiplied by 25 squared multiplied by 60 multiplied by 1/3. Cool? At this point, I'm going to get my calculator, and I'm going to start punching these things in. And that's what I would recommend you doing as well. So let's see. Please remember, if you're trying to type this into a computer or a calculator and you're trying to do 1/3, if your calculator has parentheses, 1/3 is going to be written as parenthesis 1 divided by 3. That'll be 1/3. Or if your calculator does not do that, you can always try and use the rounded decimal form, which would be 0.333. Cool? This is infinitely repeating, but as long as you get down to the thousands place, then you should be good. All right. So, and then of course, pi, you can either leave pi in there, the answer in there, or you can do pi as 3.14. So I'm going to do all of these together. So I got 3.14 multiplied by 25 times 25 again, because it's squared, multiplied by 60, multiplied by 0.333 equals, and we get a volume of 210.75 feet. And because we're talking about, feet, because we're talking about volume, this is going to be cubic feet. And there's our final answer, 39,210. Cool? Next problem. Let's switch over to purple. Trevor used the reasoning about shadows to estimate the size of a tank of a water tower in the shape of a sphere. So now we're working with a sphere. Once again, a sphere is drawn by making a circle with like kind of an oval in the center of it, such as like that. He estimated the diameter of the water tank is about 30 feet. So once again, let's see if I can do this a little bit better. That's a little bit better. The diameter goes from one side all the way over to the other side. So from this side all the way over. And the diameter of this sphere is going to be 30. And again, we're dealing with feet. What is the approximate volume of the tank? Once again, a lot of this simply comes down to remembering what the actual volume of a sphere is. Volume is equal to, for this one, it's kind of weird. It is the 4 times pi r cubed over 3. And just like beforehand, all you're going to be doing is you're going to be plugging in your radius. And that's all you need for this one. In fact, yeah, that's all you need to do. Plug in the radius for this one. That's as far as I'm going to go on that one. You can solve the rest of that one on your own. If you guys do have any questions for me, please feel free to reach out, and have a great rest of your evening. Bye.